This lesson is on some of the challenges we can have in Matlab when we try to add two polynomials. So let's say we want to calculate the closed loop transfer function of this system. We're given g, we're given h. We can do the algebra to figure out what the closed loop transfer function is, but in the end we're going to have to convolve some polynomials, right? The numerator of g with the denominator of h. And in the denominator we'll have to convolve these guys and these guys, but then add these two polynomials together. So let's try to do this and see what happens. Ng equals 2, 3, 4, 6. So we'll just build these guys. Dg equals 1, 8, 1, 5, 10. Nh equals 1, 1. Dh equals 1, 4, 5. So I have all the input data of g and h. Now I need to start building the closed loop transfer function polynomials, right? So we'll go after the first one, the numerator, which is ng convolved with dh. So num closed loop transfer function equals convolve ng with dh. And that works. Let's now build the denominator. So we'll convolve this guy and then we'll add it to the convolve of that guy. Den of the closed loop transfer function equals convolve dg with dh, and we'll add that to convolve ng and nh. Aha! So to add polynomials, they have to be the same dimension, because in Matlab you're adding two vectors and the vectors have to be the same size. So let's go ahead and let's figure out what this is separately and this one separately. So we'll define dg dh equals convolve of dg and dh. There it is. And then the second one will be ng nh equals convolve ng with nh. So right away we can see they're the same size. If we wanted to know the actual size, there's a command called size in Matlab. You just type size and the vector you want to see the size of. So dg/dh, that's 1 by 7. Size of ng/nh is 1 by 5. So we know they're off by 2. So what we can do is we can go ahead and pad ng/nh with a couple of leading zeros, and it'll be the same size. So let's do that. ng/nh padded equals, we'll pad it with 2 zeros because we need to get to 7 elements. So there's 2 zeros plus the original ng/nh, and there it is. Just check the size of that guy to make sure. ng/nh padded, and it's 1 by 7. Now we can add the two together. So den of the closed loop transfer function equals dg/dh plus ng/nh padded. And it added them this time with no error. So we've got the denominator of the closed loop transfer function, we've got the numerator. We can now build a transfer function. G closed loop transfer function equals TF num of the closed loop transfer function with the denominator of the closed loop transfer function. And there it is. So we can build the closed loop transfer function. If we wanted to use convolving polynomials and add polynomials, we just got to track to make sure they're the same size when we add. And that completes the lesson.